We said that when we take two expressions of the type, in this case, x minus 5 times x minus 2, and we say that's going to be equal to f of x, what we end up with is this curve here that's called a parabola. And so let's just take a look at a couple elements of that. So the first is, when we look at x minus 5 times x minus 2, we know that when x is equal to 5, that this first expression, x minus 5, will be equal to 0. When x is equal to 2, the second expression here, x minus 2, will be equal to 0. When we look at the graph, we can see that the y value for this function f of x is equal to 0 at x is equal to 2 and at x is equal to 5. So just by looking at the structure of this, we can tell where our curve is going to cross the x-axis. These 2 points here are called the x-intercepts. One of the things that is true in a parabola is that is a symmetrical curve. It has a line, a vertical line that runs down the middle that is sort of like a mirror. Every point on the right side of that has a reflected point on the left side. The one point that doesn't have a reflection is this point that is, when the curve opens up, the point right at the bottom, or the vertex, is the one point that doesn't have a reflection point. Now, one of the things that you'll note is that the x value of this point right here is always going to be halfway between these two x values, the 2 and the 5. So halfway between 2 and 5, we have x equals 3.5. So if we then plug 3.5 in for x here, we'll be able to figure out what the vertex of our curve is going to be. In this case, it's negative 2.25. So this point right here has a coordinates of 3.5 as the x and negative 2.25 as the y. So again, by looking at this equation here, you can first figure out that the two x-intercepts are going to be at x equals 5 and x equals 2. Halfway between 5 and 2, or at x equals 3.5, you will have the x value of your vertex. When you plug 3.5 into your equation here, you will get that f of x, or f of 3.5, is equal to negative 2.25. So that gives us the y value for our vertex. Okay, when we multiply these two out, and that means doing this sort of box multiplication, where we multiply x minus 5 times x minus 2, and we end up with x squared minus 5x minus 2x plus 10. We have 4 different products here. We have x times x is x squared, x times negative 5 is negative 5x, negative 2 times x is negative 2x, and 10. When we add those together, we end up with x squared minus 7x plus 10. Notice that the negative 2x and the negative 5x combine to give us negative 7x. So the graph of x squared minus 7x plus 10 is the same as the graph of x minus 5 times x minus 2, because they are the same expression. X squared minus 7x plus 10 is equal to x minus 5 times x minus 2. One of the things you'll note here is that another point of interest for us is where this curve crosses the y-axis. So every point along the y-axis has an x value of 0, just like every point along the x-axis has a y value of 0. So if we say, well, we want to figure out where this point will be on the y-axis, we can say, well, what happens when x is equal to 0? So when we go to our equation here, if we plug in x is equal to 0, well, the x squared will be 0, the negative 7x will also be 0, and only thing that will be left will be the positive 10. So that tells us our y-intercept here at 0, 10. And we could also have found that by just multiplying the negative 5 times the negative 2 and getting this positive 10. And so we have this point here. And so now we have 1, 2, 3, 4 points, the two x-intercepts, the vertex, and the y-intercept. Well, there's one more point here. So we have our x-intercepts at 5, 0, and this should say at 2, 0. I don't know why it doesn't, but and then we have our y-intercept at 0, 10, and then we have another point, which is the reflection of the y-intercept across our line of reflection here at, in this case, the point 710. So it has the same y value as our y-intercept, but because it's the y-intercept is 3.5 units to the left of this line, this point will be 3.5 units to the right. One quick way of doing this is saying you take the x value of the x-intercept of the vertex and just double it, and you'll get the x value of this point right here. So very quickly we can come up with 5 different points, and from those 5 points we can sketch a rough version of the graph. And so you'll see that when we go to x minus 4 times x plus 2, now we have our x-intercepts are at x is equal to positive 4 and x is equal to negative 2. When we multiply it out, we get x squared minus 2x minus 8. We have a y-intercept down here at negative 8. We have our vertex. The x value is halfway between positive 4 and negative 2, which means that it's at x equals 1. When we plug in 1 for x here, we're going to end up with a y value of negative 9, which gives us the y value of our vertex. And then we also have the reflected point of our y-intercept, which is just on the other side of the line here with the same y value as our y-intercept, which gives us this point here at 2, negative 8. Okay. So one of the things you'll notice is that both of these curves have exactly the same shape. In other words, the only difference is that one of them is moved somewhere else on the coordinate plane. That is true for this one as well. One thing to make note of here, though, is that we have, in this case, x minus 3 times x plus 3. So instead of having two values that have different absolute values, our negative 3 and our positive 3 are opposites of each other. They have the same absolute value. Notice what happens when we do out the multiplication here. We end up with a negative 3x and a positive 3x, and that means that when we combine our terms here, 3x plus negative 3x gives us 0x, so we end up just with the x squared term and the negative 9. You'll notice that in that case, the vertex is going to be somewhere along the y-axis because it's going to have an x value halfway between negative 3 and positive 3, which will put it right along the y-axis here. Another one we want to pay attention to is when these two have the exact same value. We have an x minus 4 times an x minus 4. When we multiply that out, we get x squared minus 8x plus 16. So in this case, we have that the x value of the intercept is 4 and another 4. And so what that means is that both the x-intercepts are at the exact same point at 4, 0. And then the x value of the vertex is halfway between those two. So since they're the same, the x value of the vertex will also be at 4. So what that means is that when we have x minus a number times x minus that same number, our curve is going to have its vertex right on the x-axis somewhere. Okay. And now notice that this curve for the first time actually has a different shape. It's narrower. And the reason for that is that the number that's multiplying the x squared here is no longer just 1. It's now equal to 6. And when it's 6, it ends up narrowing our curve. If you remember from our function transformations, when we multiply the x values by a number greater than 1, it actually narrows our curve. And so we're basically replacing our x squared with 6x squared here. This number here doesn't have any effect on the shape of the graph, only this number here. So when this number is greater than 1, our graph gets narrower. And this is another example where it's narrower because, again, we have a number greater than 1 multiplying the x squared term. In this case here, the thing to take note of is that we now have, instead of a positive number multiplying x squared, we have a negative number. And what that means is that now our parabola opens downward, and our vertex, instead of being the lowest point, will be the highest point. Another thing to note here is that when we did the multiplication here, it was 2x minus 5 times negative x plus 0. So because it's plus 0, we don't write the 0. So we end up with just multiplying negative x times 2x minus 5. And that gives us negative 2x squared plus 5x. And this is what the graph of that looks like. And again, this is another one where we have a negative x squared term. And again, that means that it opens downward. One of the other things to make note of is that when we multiplied x minus 5 times x minus 2, well, if we look at the lines that we're multiplying, we have this blue line here is x minus 5. The green line is x minus 2. So notice that when the green line is passing through the x-axis, the curve is passing through there as well. When the blue line is passing through the x-axis, the curve is passing through the x-axis as well. In between these 2 points here, the green line has positive y values, the blue line has negative y values. When we multiply a positive times a negative, we get a negative. That's why our curve is below the x-axis here. It has negative y values. But as soon as both green and blue have negative y values, then our curve has positive y values, again, because we're multiplying a negative times a negative. Similarly, when we go past this point, we're multiplying a positive y value for the blue line times a positive y value for the green line. So we again end up with positive y values for our curve. So that way we can sort of predict where the curve is going to be negative, where it's going to be positive, and where it's going to be positive on the other side. And again, all of this is 100% symmetrical.